She's like, yeah, I just drew them. So okay, I'll do that.
Corinne is not a happy camper when it comes to mastering. Okay, I guess we got a student in the bathroom. But I'm mindful of time because students asked me to record this again because I didn't record the last one, but I'm going to record these. So students, I'm trying to respond to student requests as per my multiple emails. But you guys got my email on the given information?
Mhm.
Yeah. Don't print it out and bring it. You can print it out, just don't bring it to the test. I'll provide the stuff. But it seems like you guys want to know what you're given so that you can have to look at and study. So what I'm doing here is what's called an emporium model, where I go through, I solve some problems, and then I let you guys work on it. I go around and see how you're doing and see if I can do the best to correct anything that's misunderstood. And these are, I mean, they're not going to be the exact same questions like this on the final, but these concepts are there, and many of them you may have forgotten, just because, it's a whole semester long kind of thing. But, does anybody have any questions about anything before we start? Nope. Okay, so determine the number of protons, the number of electrons in each ion. So number of protons, number of electrons, number of protons you get from the periodic table. You will be given a periodic table, and for nickel, it's got 28 protons to start. So, and 28 is just the atomic number. I'm sorry if I'm going real back far, but I'm just making sure everyone gets it. The atomic number there, 28, that's the number of protons in nickel. Watch my thing crash. See the crash? Yes, it crashed! Yay, technology. Okay. So it starts with 28, and the plus 2, that means it's missing 2 electrons, so there's 26 electrons there. Likewise, sulfur is going to have 16 protons, and with the minus 2, it means there's 2 extra, so that's 18 electrons. Same thing with bromine. Bromine has 35 protons. The bromide is going to have 36. Chromium plus 3. Chromium has 24 protons. The plus 3, you lose 3, so 21 electrons. So now I want you to do 58. I'm going to go around. I'll go ahead and give you the number of protons. There.
I'm writing everything.
All right, just keep on going. Yep. You don't have to look. Yeah. You have to strain your ass. Man, I have become cool again. Yeah. Well, I'm glad. Hey, this is studying for the final. Must have been the cat pictures. I like the tri-cat. That was pretty. So just solving problems, and so I'll solve one, you solve one. I make sure that you're getting it and studying for the final. Yep.
Okay.
These three, and then.
Right.
Yep.
We're doing this right. Okay.
All right, you got it.
Yeah.
Okay. Okay. Any questions with this? All right. Give each compound an appropriate name. So A is going to be tin to oxide, and if you recall from the email I sent out, you are going to get this chart. So I'll write the other, okay, so it's tin to oxide. Now the way you balance charges here, sulfur is right underneath oxygen. It tends to be -2. Oh, and I guess say, so tin oxide there, tin to oxide. If you look at the periodic table, oxygen, you can see sulfur. It's 2 over, so -1, -2. Oxygen from the periodic table, these will tend to form -2 ions. So that's why you knew that tin was the +2 ion. And is it going to crash? If I'm fast enough. Oh, and it crashed. All right. So sulfur is -2, just like the oxygen. And the -2 times a 3, this is all -6. And then because there's a 2 chromium there, this is going to be +3. You understand my logic there? So B is going to be chromium 3 sulfide. And C, it's rubidium as an alkali. And the alkalis and alkyl nurse are always +1, +2, respectively. You don't have to put the charge in there. So that's rubidium iodide. And Z is same thing with the baryons and alkaline earth. Barium bromide, like so. Anybody have any questions with this? Okay, so let me. I'll even write the name for you because you don't have the bare table, so that's hard to see actually. Let me. I'm writing the elements there. So Ba is barium, Fe is iron, Pb is lead, Sr is strontium, S sulfur, Cl chlorine, I iodine, Br bromine. Just to make your life easier in writing this out. Guess I'll just wait. You erased it. Can I see? Yep. Oh, you don't need to put the 2 there.
Oh, why?
Because it's an outlier. It's always 2. It's only one there. You see something in the middle. So. It's right here.
Oh,
This is an outlier.
that sounds.
So these two you put the number in. So.
Oh, okay.
But I mean, there's some zinc is always +2, silver is always +1, but you're not going to be given anything that ambiguous. But just sorry. So I just want to let you know.
No, this is-
What's that? Writing on names. So the first one, so BAS, that's barium sulfide. So I just went over a problem and then we have the name. So the next one. So CL, it's a halogen. It's Okay. But the nice thing is you get the chart. So okay. So let's look at this. Calculate the number of atoms in each. So here for A, we have 5.18 grams of phosphorus times mole phosphorus, and phosphorus is 30.97 grams phosphorus times 0.02 times 10 to the 23rd atoms phosphorus per mole phosphorus. So 5.18 divided by 30.97 times 6.0 to each 3. So then 1.01 times 10 to the 23rd atoms phosphorus, and I'll just do it again for fun. 1.87 grams bismuth, mole bismuth, number 208. Seven divided by 209. This is 5.39 times 10 to the 21. So why don't you do platinum? And simple, look it up. It's 195 grams per mole. Did anyone forget his or her calculator? Did Justin do his calculator? Oh, you did. Oh, you did. Go back there.
It was the other one.
Oh, okay. I just like platinum. And I didn't do that one in the other class, so I was. Yep, you got it. You got it. All right. Making my job easy. Okay. So here is, now there's not going to be a problem this hard on the final. There are short problems, but this encompasses many different concepts. Okay, so this is just so that you can, well, it's rather than doing all these tiny problems, this one big one that here has percent yield, has theoretical yield, linear reagent, and percent yield. So there's a couple questions of each. So, but let me go and do this. But before I start, get the molecular weight. So lead plus 2 is going to be the same as lead. An electron weighs about 1/2000th of a proton. So 2 electrons missing is going to be about 0.001 atomic mass units. So it's not even, and here lead doesn't even show up there, so it's only the tenths. So the ions, and there's not an ion test, but it's the lead's mass here, it's going to be 207.2. So 207.2 grams per mole. KCl, so potassium 39.1, chlorine 35.45. So 39.1, 35.45. So this means that's going to be 74.55. Lead chloride, so 207.2 plus 70.9, so 278.1. Okay, grams per mole. So I'm assuming you. So do you guys know how I got that? How I got the molecular weights? Okay. So the way we do this problem, so let me read it. Lead ions can be precipitated from the solution using this reaction. Lead plus 2 KCl makes PbCl2, lead 2 chloride, plus 2 potassium ions. When 25.8 grams of KCl is added to 25.7 grams lead ion, precipitate forms. They collect 29.4 grams of the product. What's the limiting reagent, theoretical yield, and percent yield? So to figure out both limiting reagent and theoretical yield, you have to do it twice. So 28.5 grams KCl times mole KCl per 74.55 grams KCl times mole lead chloride to 2 moles KCl. I'm getting that from the balanced chemical equation times 278.1 grams PbCl2 to mole PbCl2. And if you do this, 20.5 divided by 74.55 divided by 2 times 278.1, and this is 53.2 grams PbCl2. And then the other one, 25.7 grams Pb plus 2, mole Pb plus 2, 207.2. Same one going across. And this is 34.5. So since this one is smaller, this one is the limiting reagent. It's also the theoretical yield. Okay, so I should say the limiting reagent is lead plus 2. And now, so theoretically, or the percent yield, this is the actual, all of the theory, times 100%. Equals 29.4 over 34.5. Four, 34.5. This is 85.2%. So okay, recap with this one. So we have this chemical reaction. We have 28.5 grams of KCl reactant, 25.7 grams of lead plus 2 reactants, and we got to figure out what is the limiting reagent and theoretical yield. So we go across it twice. So the first step here is the molecular weight. Second step is to relate the reactant to the product, and there's a 1 to 2 molar ratio here. It's only a 1 to 1 ratio here, but 1 to 2 here. Then the molecular weight of the product. Same one down here, like I said, but it's a 1 to 1, and of course the molecular weight's different for the reactant. And we get 53 and 34 grams. The lower one is limiting reagent, so this is limiting reagent is lead plus 2. The theoretical yield is 34.5, and then the percent yield is actual over theoretical. We're given the actual, so the percent yield is 85.2%. So, questions with how to do this? Okay. Alrighty. And now it's your turn. I will go ahead and give you the molecular weights of this. Ammonia is 17 grams per mole, carbon dioxide is 44, urea is 60, and water is 18. Yeah.
So it's the grams we use for the percent yield will be the grams of PB, because that's the one that's already in the solution.
Oh, so this was given, the 29.4?
Oh, 29. Yeah, 29.4, but then underneath it is the theoretical.
Yeah, and the theoretical yield is right here.
And why would we use that one instead of the one we found with KCl?
Because that's not how much it should be produced, because the lead plus 2 is limiting reagent.
Oh, okay.
Because the theoretical yield comes from the limiting reagent, and the limiting reagent is the lowest amount. Like, if you have 1,000 fries and 10 toys, you can only make 10 Happy Meals. because you're limited by the toys. So in this case, we're limited by the PB plus 2.
Okay.
Other questions? Okay. All right. Oh, and just forget the kilograms, just 2 grams. Don't worry about them multiplying by 1,000. Is anyone getting stuck? Should be 247. What do you guys like better, candy or chocolate? Or I know chocolate is candy.
Chocolate.
Chocolate, okay. Darn, that's not my candy. Alright. This is This is around 60 urea and
Yeah, okay.
So it should be 240.7. Which you other than you have the right logic. Okay. All right, like I said, this question's too hard to be on the final. It's multiple step. They're all really quick steps. So, molarity, A is easy. Molarity means moles per liter. So, 3.25 mole LiCl divided by 2.78 liters, just straight across. So 2.25 divided by 78, 1.17 mole LiCl per liter, which is 1.17 molar. So moles per liter means the capital M molar. This one is a little bit different, so 28.33 grams glucose times mole glucose over 180 grams glucose times, just divide by 1.28 liters. 0.123 molar glucose. And now you guys can work on C if you want. Oh, wait. So in the so I'll go ahead and give you the molecular weight there. Man, this stuff always makes me so tired. Do you guys feel tired too? Just thinking, it's like, it's not even hard thinking, it's just math, you know? But studies show that doing thinking like this is about as energy consuming as jogging. It's 100 watts. Well, jogging might be a little bit more consuming for me because I'm bigger. But for the average size person, it's if Remy was jogging, it's the 100 watts. Mine's probably a bit more.
Yeah, just do the first one.
Okay. Okay. Ready? Okay. Alrighty. Looks like you're getting that. Anybody have any questions? It's easy stuff, but it's just, you know, burns the brain. Okay. I had a question like this on my lab, and there's a question like this on the final, so I'm going to go over it in a little bit more detail, because a lot of students got it wrong, actually, in the lab. So the molarity of nitrate in each solution. So the first one, so there's two ways you can do this. You can do it the formal way. So I'll write out the formal way. So we have 0.15 moles potassium nitrate per liter times mole NO3 minus per mole KNO3 equals 0.15 mole NO3 minus per liter equals 0.15 molar NO3 minus. So you can do that. Or you can So still same. So for calcium nitrate, part B, there's 2 moles nitrate ions per mole of calcium nitrate because there's a 2 here. Okay, and then you get it that way. The other way you can do it, the even easier way you can do it, is just because there's a 1 here, you multiply by this by 1. Because there's a 2 here, this is 0.3. And since there's a 3 here, it's just 0.15 times 3, or 0.45. So, whichever way you want to do it. So why don't you work on 56? I should put a zeros. I'm sure my math teachers, my high school math teachers are all upset. This is my hungry day too. I do a weight lifting routine, and this is my lift heavy week. So I know I'm hungry all the time this week, which is good because it's the week after Thanksgiving. So I'm almost done with my turkey. Just thinking of that. Eating turkey after class. And there's 1 mole. It's just 1 mole chlorine per mole NaCl. I was over there.
Oh yeah.
Yeah.
I did that.
Is it just me or is the screen shrinking? It used to be bigger? Or is it just my laptop? I guess there is. Okay. I guess there is screen out to here. Okay. You don't have to do all that, right? You can just take the B multiplied by 2 and C multiplied by 2. You see why? Because they don't see all 3 who's C, there's 3 things who's multiplied by 2. Good way. Long way will never go. Dimensional analysis, I should say. I mean, I know I've written out the dimensional analysis way, but I mean, you can just look at the 3 here and multiply this number by 3, and the 2 here for the CL2 and multiply that number by 2. So any questions with this? Okay, so this next one to use an equation, m1v1 equals m2v2, or the molarity of 1 times the volume of 1 is the molarity of the second times the volume of the, second. Sometimes it's C1v1 equals C2v2. Whichever one, concentration of 1 times the volume of 1, whichever way you prefer. Okay, so, but the way this one works then, 123 milliliters times 1.1 molar equals 500 milliliters times our unknown variable, to say x. So 123 milliliters, 1.1 molar divided by 500 milliliters equals x equals 1, 2, 3 times 1.1 divided by 500. 0.271 molar glucose. So, why don't you try then 62? Oh, sorry, 2 sig figs. You're on mute. Okay, you got it. Alright. Alrighty, nice job. Now, so if you're wondering how I set up for class, this is how I do it. Okay, so this solubility chart will be given to you. Of course, if you saw it by the scan I sent you, it's going to be a black and white copy that I literally cut out of I photocopied the textbook and I cut it out with paper, with scissors, and put on another piece of paper and photocopied that. So it's not as pretty as this. But when you look at these, you look at the positive ion, so the first ion is a positive ion of the first, and then the second ion, the negative ion of the second, and then the positive of the first and the negative of the, the positive of the second and the negative of the first. So this one here, look for lithium sulfide, and if you see there top nine, all alkalis are soluble, so lithium sulfide is soluble, barium iodide, so halides tend to be soluble, with the exception of silver, mercury 2, or lead 2. So that's not an exception. Therefore, this one is no reaction. So potassium chloride and calcium sulfide. So it's potassium sulfide. All potassium salts are soluble. Calcium chloride. Chlorides are soluble with the exception of silver, mercury, or lead. Calcium is not silver, mercury, or lead. This one is no reaction. So chromium and carbonate. So carbonates tend to be insoluble with the exception of alkali and ammoniums. Chromium is not an alkali or ammonium. Therefore, it will form chromium CrCO3. Oh, it's the 2 ion. Okay, that's nice. Solid. So this one there's no reaction. No reaction. Chromium plus NaBr. So what a lot of students were doing in the last class, they were putting Na2 and Br2. That's not a molecule. It's NaBr. This is aqueous. So you gotta leave plain old NaBr. Well, I guess it's gonna be multiple choice, so you don't have to worry about balancing that closely. But then there's gonna be a 2 here. So balance out that. Okay. All right, now part D. So sodium is an alkali, so sodium chloride, that is definitely soluble. Then iron hydroxide. Hydroxides tend to be insoluble with the exception of alkalis and ammoniums. Therefore, iron hydroxide is insoluble. So you write out iron 3 hydroxide, FeOH3, solid, plus, then we have NaCl. So then balancing it, you'll need 3 here and 3 there. And then you're done with that. So, questions with this, how to do it? Nope, okay. Here is your turn. No carbonates or did A and D?
Oh yeah, I did A and D. And then now I'm doing C.
Okay. This one, noon class took a long time. This one too. It's HG2. So Hg2Cl2. Cl2. But I mean, that's just a little eliminating point. And rotate. If I turn it here, I'll rotate the screen.
Yeah.
Oh, like do a barrel roll.
For Hg2Cl2, it's Hg2Cl2, but for NH4Cl.
Yeah,
it's
yeah.
2.
Because Hg2 plus 2, it's polyatomic ion. It's a special case. So, okay, yeah. So did you guys hear that? It's I know it trips on a lot of students. The Hg2Cl2. It's you keep that as in twos. It's because Hg plus 2 is a polyatomic ion. So that's the exception. So what's chemistry class without a couple exceptions? Just taking time. You can see that they react, so. No, students have a hard time with this. So it's taking a while, it's fine. But hey, you don't have to memorize the chart.
Yeah.
Even I don't have it memorized. I didn't know that strontium sulfate was insoluble. So I think, yeah, we got more stuff, but that's going to take. I mean, you guys aren't even done with this one yet, so this is where we're going to end. It's also where the noon class ended too. We got less than 4 minutes left in class. So stick around, go if you want to go through it. But I mean, like we're done.